Hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 8 of the daily code challenge of January month, and we again have an easy question in front of us. Let's see what the question is. And by the way, if you're not used to the topic of trees, I'm sure you won't be finding it easy, but definitely it will be a starting point for you. So let's quickly see what the question is. It's question number 938, range sum of BST. So if you're not aware, BST basically means the binary search tree. And if you are aware of what a binary search is, so basically, we are trying to replicate the same behavior in the form of a data structure, and this particular data structure will replicate the behavior of a binary search. That's what the idea here is. And let's see what the question is. Given the root node of a binary search tree and two integers low and high, return the sum of all, that is, return the sum of values of all nodes with a value in the including range of this. That what that means is, see, the idea here is we are given a root, okay, and we are given two variables which are called low and high. Low is the integer, high is again integer. What does it mean? Is, see, you will have to go through all the nodes in this particular tree, and whichever node is between this range, okay, for example this is the 7 and 15, right? So whichever node is in this between this, okay, remember they're saying inclusive range, that means including 7 and 15. If any value lies between them, you will have to take that, and we basically have to take the sum of all such nodes, okay. So whichever node lies in this particular range inclusive of these two, you will have to take the sum of that, okay. We'll see examples also. So in this case, as you can see, which are the nodes lying between 7 and 15? Definitely 10 is lying between 7 and 15, okay. 5 is not lying between 7 and 15. 3 is not lying between 7 and 15. 7 is lying between 7 and 15. So 10 plus 7 is 17, okay. Then again 15 lies between 7 and 15. So 17 plus 15, okay. And again then 18 doesn't lie. So 17 plus 15 is the answer. As you can see here, that's what I mentioned. This is 17 and this is 15, and they're adding that to make it 32, okay. So that was the basic idea. Let's quickly see other example also. Here they're giving 6 and 10, okay. So basically, idea is very simple. If you don't know also this data structure, basically you can just find out. Okay, go through all the nodes. Whichever node lies between this range, you can add it, and finally we get the answer. Okay, that's what the idea here is. But remember, this question is not something like that. Remember, if you get this kind of question in a interview, you are expected to use this particular behavior. Okay, that is see, it's a binary search tree, right? It's not a simple tree. Okay, without any behavior. Binary search tree has some behavior. Okay, so you will be required to use that property to make your solutions more efficient, as simple as that. So what that means is, try to understand this fact here. I hope you know what is binary search. What that means is, try to, if you don't know, let me quickly explain it. I will just take a small time. See, what that means is, suppose I have 10 here, okay. So all the elements to the left of 10, okay, that is the left subtree of 10, will have a value less than 10. So you can see 3, 5, and 7 are definitely less than 10, okay. And similarly, all values to the right of 10, that is the right subtree of 10, will have values greater than 10. So you can see 15 and 18, they are greater than 10, okay. So now come to this particular subtree, okay. That's 5, 3, and 7 come to this subtree. So all values to the left of 5 will be less than 5. You can see 3 is less than 5. Similarly, all values to the right of 5 will be greater than 5. You can see 7 is greater than 5. So that is the behavior of a binary search tree. I hope you know this concept. If you don't know, please go and Google it out. These things are important. Okay. Now, see, this is a data structure. Okay, trees are a data structure. They are very, very useful, and definitely you should be knowing these kind of behaviors. Okay, binary search tree is the most basic kind of basic thing you should be knowing if you want to appear in a tech interview. Okay, tech coding interview. So now let us understand what we can do with this behavior. Okay, so try to understand this fact. Let's see this. See, suppose I come to 5. Okay, is 5 in the range of 7 and 15? Obviously, 5 is not in the range of 7 and 15. So what I can conclude now, just try to understand this fact. Any value to the left of 5 is definitely smaller than 5. Okay, I already know that 5 is not in this range. Okay, 5 is not in this range, and why it is not in this range? Because it is less than low. Okay, it is less than 7, that's why it's not in this range. So after knowing this fact, should I be going to 3? I know that anything left of 5 will be less than 5, and by the way, 5 itself is not in this range because it is less than 7. Okay, so should I be taking the left subtree? Obviously I should not be taking the left subtree. And by the way, should I be taking the right subtree? Definitely you should be taking the right subtree, because right subtree, see, 5 is not in this range. 5 is not in this range. Why like that? Because 5 is less than the low. Okay, so we ultimately have to try for a value greater than 5. So definitely going for the right subtree makes a sense here. Okay, that is the basic idea. Similarly, come to this 15. Okay, suppose I'm in this 15. uh then yeah, you can see here 15 lies in this range, that is fine. Okay, but should I go to the right subtree of 15? Try to understand this fact. See, anything to the right of 15 will be always, greater than 15. Okay. So, okay, by the way, 15 is the, edge case here, but just think of it as a 16. Okay. So 16 is present here. Okay. 16 itself is not in this range because it is to the right of high. Okay. It is greater than high. That's why it is not in this range. Okay. So should I be going for the right subtree of the that particular value? I should not be going. Okay. So these are the few things which we'll be including in our solution. Let's see what our code is. So in my case, I will be calling it as a depth. See, there are two ways to traverse any tree. One is the BFS, another one is the DFS. BFS basically means in a breadth first way, that is level by level. Okay. For example, we will go for 5 and 15, and only then we'll go for 3, 7, and 18 because they're in the next level. But I will be using the approach of DFS because I find this more, because it's easy to code, at the same time, it's more imaginable what we are doing. Okay. So what that means is I will be going like this. Okay. So 10, 5, and 3, and then I will come back and go to 7, and similarly 15 and 18. This is the basic idea, but obviously we'll be also using the property of the binary search tree, and let's see what we are coding. Okay. Let me quickly zoom in, and then we can start. So I am simply declaring a sum variable. Okay. Then I am declaring a DFS function. Okay. This is the basic idea. I am calling that function, and finally I am returning the sum. Okay. Initially sum is 0, and yeah, that's what it is. Then I am calling this function with the root given to me. Okay. The root is given to me. And by the way, what is the structure of this tree? Each node in this tree is basically object of this class. Okay. So each node in this tree has these values. Okay. It has a dot val, that is going to be a value which is going to be integer. By default it is 0. It will have a dot left and dot right elements. Okay. What is left is going to be, by the way, it will be none initially, but if you pass something it will be assigned. Similarly, what is right will be none initially, and if you pass something it will be assigned. Okay. So that's what it is. Even see, left is also will be object of this class only, and similarly right is also going to be object of this class only. So I hope you understood this. Each node in this tree is going to be a object of this particular class, and so they will have these particular members. Okay. So now let's come to the my solution. So I will quickly going through this function what we are doing. Let's see here. So this is the base condition. If root is equal to none, simply return. Okay. I remember I'm doing DFS. If you are not sure what a DFS is, though I have already explained, but see, if you are doing this for the first time, I will definitely recommend you to go and simply in a YouTube Google it out what a DFS is. Just try to understand how it is happening, trace it out, see any video which is doing the tracing, and then come back to my solution. Okay. So yeah, that is I'm declaring non-local sum. Why I'm doing non-local? Remember, in Python, whenever you are you're referring something out of the scope of the function, you should be including non-local. Otherwise, the behavior will be unpredictable. Okay, though it may work in the Leetcode editor, but in the online editor of the your online assessment exam of your company, it may not work. Okay, so it's always a good idea to use the non-local function whenever you are referring to something which is declared outside of the current function scope. Okay, as simple as that. Then this is a base condition. If root is none, simply return. Okay. Then what I'm checking? I am checking if the root dot val. Okay. By the way, what is root dot val? See, you are seeing these values, right? 10, 5, 15. See, for example, if you talk about this particular circle, which is a node, 10 is the value here. Okay. So root dot val will be 10 in this case. Okay. So yeah, what I'm checking if root dot val is this in this particular range. Okay. So they have clearly mentioned to be inclusive. What that means is, see, I have to consider both low and high, and that should be included in the range. Okay. So in Python, how to ensure that? See, low will be included in Python, but high will not be included as such. So I have to do a +1 here to make high be inclusive of this range. Okay. So in Python, you have to do that for the ending value. Okay. This is a convection. You can this is how it is being done. Okay. So if this is in the range, I am well and good. Okay. So what I will do, I will simply update my sum. Sum is equal to sum plus root dot val. Okay. Then see, remember, because the root dot val is in this range. Okay. So I cannot say anything much about its left and right subtrees. Okay. Its left subtree may be having elements which will be in this range. Similarly, its right subtree may be having elements which is in this range. So I will be doing this. Okay. I will be going for both. I will be first going for the left subtree, and then I will be going for the right subtree. Okay. Remember, this is a recursive function. We are using stacks to internally the stacks are used to simulate this kind of recursion. What will happen is I will finish the whole left subtree first. Only then I will come to the right subtree. What that means is, see, try to understand. 10 is in this range, right? 7 and 15, right? So the left subtree of 10 will be first completed. Only then will come for the right subtree. As simple as that. Okay. Now come to the other case. If root is not in this range, what are the possibilities? Then either root is less than the low or root is greater than the high. Okay, these are the only two possibilities. See, suppose root is not in the range, what it means? Either it should be less than low or it should be greater than high. Okay, so let's see both the cases now. If it is less than low, okay, if it is less than low, what it means? It means that see, for example, the 5. Okay, 5 is not in this range. Why? Because 5 is less than the low. Okay, that's what it is. So exactly the same case, this is the code for this particular 5. Okay, so 5, the value 5 is, less than the low. So what we should do, we should not go for its left subtree. Okay, we should only go for its right subtree. So that's what I'm doing. I will be only exploring its right subtree. Okay, similarly, the this see, I'm writing here else, but what it means, it means when root is greater than high. Okay, this is the case when root is greater than high. Okay, let me write it in brackets. When root dot val is greater than high. Okay, so this is the case. What we have to do in that case, see, if it is already greater than high, should it make sense to go for its right subtree? Definitely no. So I will not go for its right subtree, but I will definitely, there could be a possibility of its left subtree having some values in this range. So I will only explore its left subtree. Okay, that's what it will do. And every time when we are exploring, we will check this. If the given thing is in this range, simply include it in the sum. Okay, and finally we are returning the sum. Okay, so though may it look easy, but if you're beginner, I am sure you will not find it easy. We are using recursion for your information. Let me tell you that if you are a beginner, so if you have to understand that, you will have to learn this concept first. Okay, so quickly let me run this code and show you. See, by the way, let me tell you that if you don't follow the BST property also, if you just do simple DFS, okay, without following all these properties, still your solution will work. Okay, I've already tried that. You can do the same. Okay, but in an interview, see, always remember in Leetcode, if you are coming, your aim should be to learn something which will help you in an interview, right? It doesn't simply mean to solve some question and go, right? You may be copying your code from somewhere else and pasting it. See, those things will not help you. You should understand the scenario that will come in the interview. See, though this question is marked easy, it will not be easy if it comes in interview, because if a easy question comes to an interview, there will be several follow-ups. Okay, there will be several follow-ups happening. So don't be very very happy that you are getting easy question. What you should be thinking is, what are the various possible approaches which I can show the interviewer. Okay, definitely you have to show at least two approaches, minimum two. Okay, or in some cases it should be three or four. Okay, you'll have to keep optimizing your solution, because there will be 45 minutes for you, right? The whole 45 minutes you have to use. If there is a blank in between, then obviously there are chances that you will not be selected further. So this is what it is, friends. So I have already shown you. If I am in an interview and this question comes, first I will do a simple DFS, okay, without utilizing the property of a BST, and then I will start using the property of the BST, and then I will go to this kind of solution. Okay, so that is what it is. Yeah, friend, that was it. And see, this question is from the trees topic. Okay, if you are not sure what we are talking about, please go and see what are the traversals for trees. It is DFS and BFS. Try to learn those things first. Okay, and then come back to this particular question. Okay, though this question is not hard, but still I will expect that you at least know what a DFS is. Okay, these these things have a meaning, right? I have not simply kept a name of DFS here. Okay, so everything in this code has a meaning. If you're not able to understand that, or if you're not able to figure that out, then definitely you are missing something. You should have some basics to understand this. Okay, that's what I will recommend for the beginners. If you're not able to understand, don't worry, just go back and have some understanding and then come back. Okay, so yeah, and that was all what I wanted to say for this question. If you have any other way of doing it, please do let me know in the comments. We can definitely discuss further. But remember, whenever it comes to tree level question, the first thing that should come to your mind is either a DFS or a BFS. Okay, you should start thinking in that particular approach. That is the hint that I would like to give you. So yeah, and that was all for today. See you tomorrow. Thanks a lot.